Assalamualaikum warahmatullahi wabarakatuh. My name is Jantsen from infant grade. Today I'm going to explain about enthalpy changes, and this is a chemistry project for my chemistry lesson to Mr. Rudy. First, I want to explain about what is an enthalpy changes. Enthalpy changes is like some sort of form or process of releasing energy. For example, there is heat energy and other energy like that. But what we are gonna explain first from the basic is the two types of changes, and that is endothermic and exothermic. So let's start with the endothermic. So first I want to explain about what is endothermic. Endothermic is a process when a chemical reaction that absorbs the energy. It absorbs the energy, making the temperature around it decrease. The surrounding of the experiment will make the temperature decrease. For example, there are many types of endothermic reaction, such as when sodium and hydrogen carbonate reacts with an aqueous solution of a citric acid in a test tube. The temperature of a reaction surrounding the experiment will be decreased. There are three more types of another reaction or experiment, such as the decomposition of limestone by heating, photosynthesis, and dissolving certain ammonium salts in water. So now I'm gonna explain about the exothermic. The exothermic is kind of the opposite of the endothermic. It's really easy. When endothermic absorbs, the exothermic will release the energy to its surrounding. In an endothermic reaction, the energy will be absorbed and the temperature will decrease. But in exothermic reaction, the energy will be released and it will increase the temperature surrounding it. For example, when magnesium reacts with a sulfuric acid in a test tube, the energy release is transferred to the surrounding of the temperature and the temperature will increase. The surroundings include the solvent, in this case, or when you do experiments, water or H2O, the air around the test tube, the test tube itself, anything dipping into the test tube, or a thermometer. Other examples of exothermic reactions include the combustion of fuels, the oxidation of carbohydrates in the bodies of animals and plants, the reaction of water in quicklime, calcium oxide. So first I want to explain the formula for enthalpy changes. So in enthalpy changes we call it as delta H. So in delta H, in enthalpy changes, the formula is equals to H product minus H reactant This is the simple part of the simple explanation for enthalpy changes. Although there are a lot of things in enthalpy changes. So the standard enthalpy changes, a pressure of 10 seconds of PA, or maybe 10 to the power of 5 PA is 100 kPa. And approximately normal atmospheric pressure, a temperature of 298 Kelvin or 25 degrees Celsius at 273 degrees Celsius. Temperature convert temperature into a Kelvin. Each substance involved in the reaction is in its normal physical state: solid, liquid. So there are three. Let me explain it again: solid, liquid, and gas. But I want to add something. I want to add a new, or maybe not a new, just adding something it's not really related to the enthalpy changes, but it's related to the states of matter. So if you think that the states of matter that you are teach in the primary school is 3 by your teacher, then they are wrong, or maybe they are not telling you the truth. In this universe or in this world, there are 4 types of states of matter, which is liquid, gas, solid, and the last is plasma. So let me tell you a little bit something that I found on the internet, and it's really interesting. So solid is something that is really hard. Liquid is water, and gas is when you boil water, or it's when you boil water. But when the water becomes gas, the gas is still being heated up. It changes its matter and not into a gas but a plasma. So in short is that plasma is a superheated gas. It reacts really easily to electricity. So if you put a plasma in electricity, it can create an explosion, or it can create something that is very, very unique. So first I'm gonna explain another thing about his law of conserving energy. The law of conserving energy states that the energy cannot be created or destroyed. This is called the first law of the thermodynamics. The law also applies to chemical reaction. The total energy of chemicals and their surrounding must remain constant. In 1840, Germain Hess applied the law of conservation energy to enthalpy changes. His law, let me read it out for you, states that the total of enthalpy change in a chemical reaction is dependent of the route by which the chemical reaction takes place, as long as the initial final conditions are the same. Calculating enthalpy changes using bond energy. We can use bond enthalpies to calculate the enthalpy change of a reaction that we cannot measure directly. For example, the reaction of the Haber process is N2 open bracket G close bracket plus 3H2 open bracket G close bracket, and an arrow arrow 2NH3 G is the formula for all of this. Let me get out of the way for a while. I'm not really good at chemistry, but this is the best I can do to explain what is enthalpy changes. So when a chemical reaction occurs, energy is transferred to or from the surroundings. It's like an exothermic or an endothermic reaction. Endothermic enthalpy changes are shown as positive values, always positive and never negative. If it's negative, it will be exothermic. Enthalpy changes can be calculated experimentally using the relationship of enthalpy change equals to negative mass of liquid times specific heat capacity times temperature changes, or delta H equals to mc delta T. The standard enthalpy change of formation delta H Fahrenheit is the enthalpy change when 1 mole of a compound is formed from its element under standard condition. So I think that's all I can explain, but the highlight of this video is something that I explained about the 4th state of matter, which is plasma. I think that's a very interesting thing, and my thoughts about primary school teacher or grade school should say the truth about the states of matter and say that there is four states of matter and not 3 states of matter. So yeah, I think in this video I'm gonna end it. Sorry if there's any misuse of language or any mistakes. I bid you farewell. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.